Hey smart people, Joe here. Almost 70 years ago, builders in this neighborhood in Austin, Texas created a radical experiment in the houses around me. They installed air conditioning. Okay, that might not seem extreme by today's standards, but at the time, central air conditioning was only found in big public buildings like offices, hotels, movie theaters, but not individual homes. So in an effort to get central air conditioning to catch on among average middle-class homeowners, the builders, who were also air conditioning manufacturers, built these 22 houses, an experimental neighborhood where researchers could study the effects of cooling air on people's health and productivity. They called it the air-conditioned village. This neighborhood and that weird social experiment that took place here set in motion a movement that would have impacts far beyond what those home builders ever imagined. Today, air conditioning is one of the most significant contributors to climate change. 10% of global electricity consumption is used to cool buildings. And worse, the energy that we use for cooling is on track to triple by 2050. Running today's cooling systems creates millions of tons of greenhouse gas emissions from running the machines themselves and the dangerous chemicals inside them. We've cooled ourselves into a crisis. This is the paradox of air conditioning. In a warmer world, more people need to keep cool to stay healthy and productive. But air conditioning the way we do it now is only making the planet hotter. See the problem? Keeping cool is setting us up for big trouble. Now, we're not about to give up air conditioning, but we need a better way to do it. And that might just be on the horizon. Over the centuries, people in hot places have developed a whole bunch of ways to keep their homes cool. Ancient Arabs and North Africans used towers called wind catchers to drive breezes into dwellings. Romans ran water from their aqueducts through the walls of some homes to cool them. But modern cooling wasn't born until 1902, when this American engineer named Willis Carrier harnessed the power of thermodynamics to cool spaces. This printing factory in Brooklyn, New York was too hot and humid. The pages were wrinkling, ink was running off the paper. So Carrier designed a machine that used a system of fans, ducts, heaters, and steam pipes to control both the humidity and temperature of the factory. And modern air conditioning was born. There was a ton of money to be made if people could be convinced to put air conditioning in their homes. So here in the air-conditioned village, engineers outfitted 22 houses with different cooling systems, fans, roofs, shades, and insulation. Then, over the next year, doctors monitored the family's medical conditions, psychologists probed their mental health, and economists even measured the residents' productivity.
The opportunity of every American for a still better living standard will certainly be enhanced.
So, what did the experiment find? Researchers concluded that not only was AC practical to use in the home, but that those with air conditioning were healthier, more comfortable, and more productive. Air conditioning, in other words, made life better. And it completely reshaped life in the 20th century. Today, air conditioning is in 9 out of 10 American homes. It enabled a massive population migration to the American South and West, which completely reshaped the country's political power in the late 20th century. Air conditioning has helped economies explode in places with unbearable heat, like Singapore and Dubai. It's changed the way we build, making skyscrapers a normal part of every city skyline. Cooling indoor air protects hundreds of millions of people from heat stroke and other health risks from high temperatures. Drugs like insulin and antibiotics can be stored safely, saving millions more lives. Today, there are roughly 2 billion air conditioners installed worldwide, and that number is growing fast, which is good for people's health and happiness, but potentially devastating for the climate. We need to fix this, but first, we need to talk about how air conditioning actually works. Warming up a room is pretty easy. Burning fuel converts chemical bonds in the fuel into heat. But air conditioners cool by moving heat from one place to another. And their secret weapon is evaporation. Maybe you remember your science teacher once saying that evaporation is a cooling process. But why? Well, when the temperature of a substance rises, it means its molecules are moving more. When a molecule in a liquid jiggles enough to break free of the rest of the liquid, it takes a little bit of jiggling energy with it, so the liquid left behind is cooler. That's why evaporation lowers temperatures in air conditioning. Here's how a typical air conditioner works. A fan pulls in warm air from your home where it meets coils full of a liquid called refrigerant. Some heat from the air is absorbed by the refrigerant, which causes the refrigerant to evaporate into gas and leaving cooler air behind. That process moves heat from inside a room to outside, which is why the exhaust from an AC blows warm air. Now the liquid refrigerant is ready to start the evaporation process all over again. This is called the vapor compression cycle. It was the idea behind Carrier's very first air conditioner in 1902, and it has driven virtually every air conditioner, and refrigerator for that matter, since. But there's no such thing as a thermodynamic free lunch. The compressor and the fans inside air conditioners eat up a ton of energy. And the hotter the weather, the more energy that they need. During some heat waves, ACs can account for up to 70% of local electricity demand. In September 2022, for example, evening temperatures in California soared over 110 degrees Fahrenheit. The power grid, straining to run millions of air conditioners, almost collapsed. Now today, fewer than 20% of people in major developing countries like Indonesia, India, and Nigeria have any air conditioning at all. But as the middle class in those countries grows, the number of air conditioning units could triple by 2050. And since cooling units take warm air inside buildings and push it outside, more indoor air conditioning could raise daily temperatures in some cities by several degrees. All of those new air conditioners will require an estimated 2,000 gigawatts of new power production, which, if it's not green energy, could make current global warming emissions targets impossible. But energy use isn't the only climate threat from air conditioners. You see, the refrigerants inside air conditioners are nasty pollutants on their own. And they used to be even worse. In the 1980s, scientists discovered the main refrigerants used at the time, called CFCs, were destroying the ozone layer. So, in 1987, nations signed a treaty to ban them. And companies replaced them with refrigerants called HFCs, which are generally found in today's models. You can think of these as refrigerants 1.0. And they are a climate nightmare because it turns out that HFCs are hundreds to thousands of times more potent greenhouse gases than carbon dioxide. So when air conditioners leak or they're disposed of improperly, all of that greenhouse pollution hits the atmosphere and, well, that's a huge reason that HFCs are the fastest growing greenhouse gas. At this rate, air conditioners could unleash as much warming power as 40 years of carbon pollution from today's power plants. And that would add almost a full degree Fahrenheit to global temperatures this century. We need to fix the way that we stay cool. Now, part of the solution, of course, is just making better buildings that need less air conditioning, like installing light-colored roofs, better windows, even fans that just pull warm air out of buildings. But we'll still need air conditioning, and refrigerants 1.0 and the air conditioners that use them just aren't up to the climate challenges that we face today. Some researchers have tried developing new refrigerants that could run in today's AC units but aren't greenhouse gases, but that hasn't been easy.
So far, it's quite tricky to find a refrigerant that has no issues. It's either like it has some toxicity or flammability, a problem, or it is very high greenhouse effect or ozone depletion, or it's expensive.
That's Hisham Jora.
I'm associate professor in Denmark at Aalborg University, and my work is primarily around everything that relates to energy and indoor environment in buildings.
Jora and his colleagues in Denmark are among a handful of scientists exploring solid materials that we might use for cooling in the future. Refrigerants 3.0. Explaining how they work, though, is a little tricky.
Yeah, thermodynamics is not always very intuitive.
Okay, to get an idea of how these solid refrigerants might actually work, grab a thick rubber band. Rubber is actually a really weird solid because if you stretch it really fast, it feels warm. You can try this, okay? Put it against your lip. It's really sensitive to temperature, and stretch it really fast. You feel that? It feels warm. Now keep it stretched and release it really quick. It feels cool. Why is that? Well, rubber is made of loosely packed chain-like molecules we call polymers. And when a rubber band is relaxed, those chains are all tangled up and don't have very much order to them. Another way of saying that is their entropy is high. But when we stretch a rubber band, its molecules get more order. The entropy is lower. And when you release it, the polymers jumble back up and the entropy increases again. There's some complicated physics and thermodynamics and math going on here under the hood, but basically when the entropy goes down, this system, this rubber band, gives off heat. And when the entropy goes up, the system takes in heat from around it. It gets cooler. Rubber is one of a rare class of solids that do this, where physical forces make them absorb or give off heat. They're called caloric materials. Scientists are testing caloric materials that change temperature when they're stretched, squeezed under pressure, charged with electricity, or put near strong magnets, hoping that they might give us a whole new generation of refrigerants that are better for the environment than liquid or gas refrigerants.
They don't have the same problems as vapor compression refrigerant because they're solid, they're not gas, they will not go in the atmosphere, so they will not be problematic for the ozone or greenhouse effect. If you would use like a solid refrigerant that is, contains lead, for example, and then you circulate some water or some coolant in it and you have leakage, then of course it can be a problem of toxicity.
But while these next generation refrigerants have shown promise in small scale lab experiments, they have still got a long way to go before they're ready to meet the challenge and the scale of how the world uses air conditioning.
The main concern is more the price when they are based on rare earth materials, and also the complexity to manufacture them, and also the durability, how they will last over time.
We don't get to rewrite the rules of thermodynamics. Cooling buildings is just a hugely energy-intensive thing to do. We've got to escape that cooling paradox as soon as we can, but solutions like caloric materials are unfortunately still in their infancy. There's a lot we can do now by making buildings just get less hot, painting roofs lighter colors, installing better windows and insulation, that kind of boring Home Depot stuff. But we need to change the way we stay cool in a big way. There's a lot at stake regarding the future of air conditioning, and for me here in Austin, it's personal. My family and I live in a city that routinely gets over 40 days a year in which temperatures rise over 100 degrees. Most years during the 20th century, Austin got fewer than 20 days a year that hot. What was once a luxury is now a necessity, and it's a similar story across the world. I mean, it's getting warmer everywhere. How much is up to us and the choices we make when it comes to things like staying cool. There's no easy answer here, but we can't deal with the heat of the future by just buying more air conditioning. The type of ACs that we make and install and how much carbon pollution they create will actually shape the temperatures that we face as the heat rises. Stay curious.